In this lesson, we will resolve complex rational expressions to partial fractions where denominator has non-repeating irreducible quadratic factor. The given rational expression here, rational expression is x squared plus 15 divided by x squared plus 2x plus 5 x squared plus 2x plus 5 times x minus 1. Here we can see that one of the factor is linear in the denominator, for which simply we can use a constant a, but the other factor in the denominator is quadratic, which is not reducible to linear factors. Therefore, we are going to introduce one constant a for the linear factor x minus 1, and we will introduce two factors in such a way bx plus c for the quadratic factor. Always we will introduce two, one with the x and the other one is constant for the quadratic factor in the denominator. So this will be written x squared plus 2x plus 5. So now let's take LCM on right hand side like we always do, and this will be written as x squared plus 15 equal to a into x squared plus 2x plus 5 plus bx plus c into x minus 1. Now for finding value of a, because in the denominator of a there is a linear factor which if we put equal to 0 we can get the value for a. So for a, put x minus 1 equal to 0. This means x equal to 1, and if we call this as equation 0 and call this as equation 1, we can substitute x equal to 1 in equation 1. From equation 1 we have 1 square plus 15 equal to a into 1 square plus 2 times 1 plus 5 plus bx b times 1 plus c into 0, because we already put x minus 1 equal to 0. So now we are left with 16 on this side equal to a into 1 plus 2 plus 5. So this will give us 16 equal to 8a, means the value of a is equal to 16 over 8, which is a is equal to 2. Now we will find b and c by comparing coefficients of the highest power of x on both sides. For finding b and c, for finding b and c, compare coefficients of highest powers, compare coefficients of what is the highest power? The highest power that can occur on both sides is x squared, and less than that will be x, because we need two constants b and c. So we will be comparing coefficients of x squared and x, which are the higher powers of x. Higher powers of x. By doing so, from equation 1, if we make comparison, x square has coefficient 1 on this side, and when we multiply a with x square, that will give us the coefficient of x square as a, and when bx is multiplied with x, that will also give us bx square, so that will give us the coefficient of x square as b. So the relation we will get is 1 is equal to a plus b. So 1 is equal to a plus b. This is the relation we get by comparing coefficients of x square. So a is already known, so 1 is equal to 2 plus b. This gives us b equal to minus 1. So now for finding c, we have to compare coefficients of x. So let's do that. Again, let's go back to equation 1 and compare coefficient of x on both sides. There is no x on left side, so therefore the coefficient of x for left side will be equal to 0. 0 equal to, let's see which term on right side generates term involving x. Here a when multiplied with 2x, that gives us 2xa, means coefficient of x in this would be equal to 2a. So let's write that 2a, and in the last term, let's see what we get. Here when bx is multiplied with minus 1, that generates minus bx. Therefore the coefficient of x will be minus b, and when c multiplies with x, the coefficient of x will be c. So from the last term we get minus b plus c. So minus b plus c. This is the relation we get when we compare coefficients of x on both sides. So from this, 0 equal to 2a is 2, already we know that, minus b is already minus 1, we know that, plus c, and this way we will be able to get the value for c. So 0 is equal to 4 plus 1 plus c. So this will give us c equal to minus 5. This gives c equal to minus 5 by substituting values of a, b, and c in equation 0. What we get is x square plus 15, x square plus 15 divided by x minus 1, x minus 1 into x square plus 2x plus 5, x square plus 2x plus 5 is equal to a is 2, so 2 over x minus 1, plus b is minus 1 and c is minus 5, so plus b would be minus 1 times x minus 5 divided by x square plus 2x plus 5, x square plus 2x plus 5. If we write the right hand side in this way, 2 over x minus 1, negative we can take common, x plus 5 divided by x square plus 2x plus 5. You can see that complex rational expression is broken down into simpler expressions on the right hand side. Let's do one more question. So example 2. And this time the given expression is x4 over x squared minus 2x plus 3. X squared minus 2x plus 3 divided by, this is x power 4 plus x squared plus 1. Here the factor in the denominator, that is not even quadratic. Probably we can factorize it as and write it as product of two quadratic factors, which are of course not reducible. Let's factorize it. x4 plus x squared plus 1. This can be written in this form: x4 plus 1 plus x squared plus x squared. And now we will be completing the square. By completing square, what we will do is x square whole square plus 1. And if you remember the completing square method, we add 2x square and we also subtract 2x square plus x square, which is already part of the given expression. This will complete our square. This will give us x square plus 1 whole square minus 2x square. So this is complete square up to this point, and we got plus x square. So this gives us x square plus 1 whole square minus x square. So now we can use the formula a square minus b square equal to a minus b into a plus b. So this will be equal to x square plus 1 minus x into x square plus 1 plus x. Or if we write it in descending order, we can write x square minus x plus 1 into x square plus x plus 1. So the denominator is now factorized, and let's write down value for the denominator. The denominator is x square minus 2x plus 3 divided by x square plus x plus 1 times x square minus x plus 1. So x4 plus x square plus 1 is product of two quadratic factors. And just like before, because both of these factors are not reducible any further into linear factors, therefore we are going to use two constants for each one of them. So thus x square minus 2x plus 3, thus x square plus minus 2x plus 3 divided by x square plus x plus 1 into x square minus x plus 1. We are going to introduce two constants for each one: ax plus b divided by x square plus x plus 1, x square plus x plus 1, and we add two more constants, cx plus d, for the second quadratic factor, which is x square minus x plus 1. Now there is no linear factor which we can put equal to 0 and get value of any constant. Here all the values we will obtain by comparing coefficients of the powers of x. Now comparing coefficients, rather we can do one more step for this x square minus 2x plus 3 equal to ax plus b into x square minus x plus 1 plus cx plus d plus cx plus d time x square plus x plus 1. So this is what we have taken is LCM on right hand side, and then we have cancelled it out with the denominator on left side. Now we will be comparing coefficients. So now comparing coefficients of highest powers of x, which is x cube. But because there are 4 constants which we need to find out, therefore we will need 4 equations. So first equation we will get by comparing coefficients of x cube. The second equation we'll get by comparing coefficients of x square. Third equation we'll get by comparing coefficients of x, and then the constant terms. So this way we are going to get 4 equations. And this way, if we compare coefficients of x cube on both sides, there is no x cube on left side, so 0 is equal to x cube can be obtained in the first term on right side by multiplying ax with x square. So that will give us ax cube. So the coefficient of x cube will be a. Similarly, when cx is multiplied with x square, we get x cube, and the coefficient there is c. So this is equation number 1. Let's call this, rather this is called 2. We already have named some equation 1. So a plus c, and now let's compare coefficient of x square. For x square we got coefficient of x square on left side as 1. 1 is equal to ax when multiplied with minus x will give us minus ax square. So the coefficient of x square will be minus a. Similarly, when b will be multiplied with x square, this will make another bx square. So the coefficient there would be plus b. And when cx multiplied with x, that will give us cx square. So the coefficient is c. And when d multiplied with x square, the coefficient is d. Therefore, this is second equation. So we got 2 equations, and now we will compare coefficients of x. Here the coefficient of x on left side is minus 2. So this is minus 2 equal to ax when multiplied with the constant 1 will generate ax. So the coefficient of x would be a. b when multiplies with minus x will generate term involving x. The coefficient will be minus b. And similarly, when cx is multiplied with the constant 1, this will give us plus cx. The coefficient of x would be c there. And d when multiplied with x will give us d. So this will be plus d. And this will be called equation number 2, 3, and 4. So a minus b plus c plus d. So the last relation we can find by comparing constant terms. The constant term on left side is 3. 3 equal to b when multiplied with 1 gives a constant, that is b. And d when multiplied with 1 gives a constant d plus d. A and C never give a constant because they already have x as their coefficient. So b plus d, and this is equal to 3. Let's name it as equation number 5. Now let's put value of a plus c from equation 1. Put a plus c equal to 0 in equation 4. Put a plus c equal to 0 in equation 4. So this gives minus 2 equal to minus b plus 0 plus d. So we got minus b plus d. Let's call this as number 6. So minus 2 is equal to minus b plus d. Let's call this as equation number 6. And also we have from 5, that is b plus d is equal to 3. Also b plus d is equal to 3 from equation 5. So when we add this, we get 3 minus 2 is 1, and b will get cancelled with minus b equal to 2d, and d is equal to 1 by 2. This is the first value we got, and now we can get value of d from 5. From equation 5, we will get 3 equal to b plus 1 by 2. This gives us b equal to 3 minus 1 by 2. So b is equal to 5 over 2. So we got value of b as well. And now adding 2 and 3. So we get adding 3 and 4. By adding 3 and 4, by adding 3 and 4, what we get is, well, we have 3 is 1 equal to minus a plus b plus c plus d, and minus 2 equal to a minus b plus c plus d. So when we add this up, what we get is a and minus a are cancelled, b and minus b are cancelled. 1 minus 2 is minus 1 is equal to 2c plus 2d. And because we have calculated the value for d, therefore we can get c. So this implies minus 1 is equal to 2c plus 2 times d is 1 over 2. This means 2 is cancelled with this 2. So 2c is equal to minus 1 is already there, and minus 1 goes on that side now. This gives us c is equal to minus 1. So we got value of c, we got value of d already, and we have value of b. Now we can get value of a from equation number 2. From equation 2, which says a plus c is equal to 0, a plus c equal to 0. This means if we put the value of c equal to minus 1 equal to 0, so this gives us a equal to 1. Hence, now we can write the partial fraction substituting these values. Substituting these values of a, b, c and d, we get x square minus 2x plus 3, x square minus 2x plus 3 divided by x4 plus x square plus 1, x4 plus x square plus 1 equal to, for a we have 1, therefore this would be 1 time x plus b. b is, we have 5 over 2, so plus 5 over 2, that is value of b, divided by x square plus x plus 1, x square plus x plus 1, and c is minus, so plus minus x, and d is 1 by 2 plus 1 by 2 divided by x square minus x plus 1, and if we take LCM in the numerator, this can be further reduced to 2x plus 5 over 2 into x square plus x plus 1 minus 2x minus 1 divided by 2 into x square minus x plus 1. This is how we can factorize complex rational expression which have irreducible quadratic factor in the denominator.